So I want to take a second to prove by non-example. So, and I have the function composition in the Desmos file. However, in this video, I'm not actually going to compose the two functions. All right. So without going into detail of logic, basically, we look at these two graphs and we know that they're not inverses. All right. So just by simple appearance, you see that there is no symmetry across y equals x. And again, we don't want to base things off of simple appearance, because what if we woke up and our eyes aren't working right and those actually are symmetrical? Well, they're not. But you can run through the composition. You'll quickly find that the two compositions are not equal to x. But I wanted to point out something else. To prove that something is false, to prove that something is not true, it is enough to prove by counterexample, by one counterexample. So I wanted to show you something. If these two functions are true, then if I find f of g of x, that's supposed to be equal to x, right? And g of f of x is supposed to also be equal to x. So let's show by one example. So I'm gonna show with the example of a number. So f of g of 1, for example. All right, f of g of 1. If truly f and g were inverses, then this result would be 1. So let's see, or at least that would be an example. All right, so g of 1. All right, essentially what I'm finding is I'm finding f of g of 1. So g of 1 is 8 times 1 minus 7. 8x minus 7 is g of x. So I'm basically evaluating it at 1. So what that means is I'm evaluating f of, well, 8 times 1 minus 7, that's 8 minus 7, which is 1. All right, so 8 minus 7 is 1. So f of 1, all I have to verify is that f of 1 actually equals 1. Well, let's see, f of 1, that's 8 times 1 plus 7. So 8 times 1 plus 7 is actually equal to 15. All right, you saw that the input of G is not the output of F. All right, so the domain and range do not appear to be flipped. All right, and that in itself, one example is, for example, what you can call a counterexample. All right, because the evaluations do not work, then there's no case to be made right here. All right, because what we've essentially proven is, well, G of 1. All right, if we look at G of x, we've basically shown, okay, G of x has the point input 1, output, let's see, input 1, output 1, right? Which means that f of x in theory should have that same point, reversed, 1, 1, right? But f of x in turn has the point 1, 15, all right? So those are not inverse points, all right? Therefore, by counterexample, you have showed that these are not inverses, all right? Remember, for two functions to be inverse, f of x, if we call the domain of f of x x and its range y, then that would mean that g of x should have a range of y and a domain of y and a range of x. But that is not true here, all right? As this example would show you, neither f of g of x results in x, nor does g of f of x equal x. And counterexample has proven the point.